Question 4. Now it says, choosing a sharper pencil, I think. Question 4 says, this train starts from rest, it accelerates, heads off, it starts. After it starts, the acceleration is given by this formula here. I'm going to find the distance. So really we've got to find the distance formula. And once we've found the distance formula, then we can plug in the 30 seconds and find out just how far that's turned out to it being traveling. All right, so let's find that now. So let's see what we got. So first of all, restate the equation. So we've got A is equal to 1/4 20 minus t. So my first job really is to expand that out. So that's equal to, well, 1/4 of 20 is 5, and 1/4 of t is just t on 4. I'll just put t on 4. There it is. And that's the acceleration. So we want to actually find the integral of the acceleration with respect to time. And that's going to equal 5. We're going to increase the power by 1, divide by the new power. We're going to increase the power by 1 and divide by the new power. So that is equal to 5t minus t squared on 8 plus c. Now we know, though, that at the start, if we were to draw this out, we've got a little, like a train here. We've got starting point here, heads off here. Here's our 30-second mark, but it hasn't moved yet. We haven't moved anywhere. So here we got time is 0, velocity equals 0. Acceleration's not 0 though. Acceleration's this thing here, but even there, acceleration is 0 at this point here. Of course, once it starts, acceleration kicks in and away it goes. But even at 0 even at 0 point, it's still going to be accelerating at 5. Looks like meters per second squared. So acceleration, is not 0 at this point. All right. So let's go ahead then and say I'll put t at t equals 0, v equals 0. Therefore, if this thing here is 0, therefore, I'll put therefore, 0 is equal to 5t minus t squared on 8 plus c. And of course, if t is 0, this is 0 and this is 0, which means therefore c is equal to 0. So therefore, velocity, which is my velocity equation there, is equal to 5t minus t squared on 8, and doesn't have a plus 0 on the end. Now, we're going to differentiate velocity with respect to time, and that's going to give us distance. So distance is equal to, I'll put v is equal to here, right? There we go. So let's have a look and see where that lands. We've got, that's going to be 5t, it's going to be increase the power by 1, divide by the new power. This is going to be t cubed now on 8, and multiply by the new power. And we're going to add a plus c to the end. Now again, same deal here. Again, at this point, t is 0, v is 0, and of course, distance will be 0. At t equals 0, distance is 0, right? So this is going to be 0 is equal to, and I'll put 5 on 2, t squared, minus t cubed on 24 plus c. That's 0, therefore we can put, therefore, I'll use that dot there. Therefore, what do we got here? S is equal to 5 on t squared minus t cubed on 24. Now, we can then take the next step, and I'll make a dividing line down here. Here's my formula. I'll write this up now. We've got S is equal to 5 on 2 t squared minus t cubed on 24. I'm going to let t, that's an E, it's not a dot there, let t equals 30. So now we're going to find the distance at 30 seconds. Therefore, I put distance at 30 seconds is ... And we're going to S equals 5 times 30 squared on 2 minus 30 cubed on 24. And I'm just going to plonk all of that straight into the calculator and see where we land. Here we go. So I've got 5 times 30 squared divided by 2 minus 30 cubed divided by 24. And we get 1125 is equal to 1,125, and that is going to have to be meters. So I think we've got a context statement there. Therefore, distance at 30 seconds is, and we've got 1,125 meters. And that would be my answer. I'm wondering if we need any more context, but I think that kind of works.